Water quality experts have learned that the powerful effects of stormwater can be reduced by strategically placed ponds in a watershed.
We have had an opportunity to identify a best management practice that we hope can become a baseline best management practice to help improve the water quality in Beaver Lake by reducing the amount of sediment that enters that lake.
We developed a mathematical model to simulate increasing flood storage in the West Fork White River watershed. And what our model showed was that if you can increase flood storage on a temporary basis, that you can reduce the amount of peak flow entering the river in any storm event in a significant way. And that should have large implications for both the export of sediment and nutrients from the watershed.
We're located about south of Fayetteville between Greenland and West Fork. We're on 638 acres. We have about a third of that's in pasture. The rest is in timber. We have a herd of crossbred Charolais and Gelbvieh cattle. Used to raise turkeys, but we got out of that.
In our area, we have what's called very flashy streams. When we get a rainfall event, the stream flow will increase rapidly, very, very quickly, to a very high level, many times the base flow. And that has only become worse over time as many issues that cause that with current modern lifestyles, all the impervious cover we have around, the great increase in drainage effectiveness we have. So, nobody likes a flooded road and nobody likes to have water standing around. So we've done a good job of making the water go away quickly. But because of that, we end up putting more water into receiving streams more quickly than nature intended or than used to be the case. And that rate of flow, combined with the volume of flow that we may or may not be seeing greater volumes of, we see that our stream banks have become overwhelmed. And in many cases, you'll see cut banks, places where there are vast exposed areas of dirt, just soil and subsoil along a stream bank that it erodes at a greater rate than is normal or than is average. That erosion the soil, then the sediment that comes from that erosion carries with a great deal of sediment and nutrient that ends up in Beaver Lake by flowing downstream. Those are not positive things for water quality, and we want to reduce that if we can. So the idea of putting in a pond it's first and foremost a flow equalization device. The pond you see behind us is our example pond, working with a very good landowner here, very cooperative man, Scott Mattke, to develop a site that would allow us to explore the effectiveness and to prove scientifically the effectiveness of this pond idea at slowing the flow down and allowing sediment and nutrients to settle. At the very least, we can allow the rate of flow to be decreased as it hits our stream banks in the area, and with there's no question in my mind personally that we'll see a great reduction in the rate of erosion and in the amount of sediment that gets carried downstream if we can implement this pond idea across a broad section. So we like the concept. It also provides a great resource for the landowner. So they can use the water that remains at the base level of the pond for whatever purpose they desire, fishing or boating or stock water, irrigation for small plots of land, various purposes. All of those are a win for the landowner. The environment is a win from reducing the amount of flow that comes down in peak rain events. We've observed at this particular pond that's been in place for a little over a year now, and we've had an opportunity to study using Baylor University, Dr. Thad Scott, who used to be a University of Arkansas professor but has now moved. Still, he's interested in our area and interested in this concept. He and his team have measured the rate of flow coming in, the rate of flow going out, and we see a tremendous reduction in the peak rate, which is our goal.
My research team studies the biogeochemistry of inland waters, and we've been fortunate enough to work with Beaver Watershed Alliance on numerous occasions over the last few years, including a project that I did with my collaborator, Brian Haggard at the University of Arkansas, and we published back in 2015. We chose ponds as the mechanism for increasing flood storage capacity in the watershed. But in order to do this, we needed to make some assumptions about what ponds would be in the landscape, where they would be, and how long they would be able to hold water in order to achieve the benefit that we were looking for. Our model showed that you could introduce as few as 20 new ponds in the West Fork White River watershed and reduce the peak flow by as much as 25 to 30%. But it also showed that increasing the number of ponds proportionally also decreased the amount of peak flow that the watershed would experience. In 2017, we initiated this project. The goal was to measure the hydrology of a small farm, build a farm pond, and then measure the effect of that pond on the hydrology after it's built. After 2 years of monitoring dozens of storm events, what we found was that the pond reduced the peak flow leaving the farm by over 100 liters per second on average. We're going to continue to monitor the hydrology and the water quality of the water leaving the farm, and we look forward to reporting those results as they continue to come in.
So altogether, we have established that we can create a win-win situation, a win for the landowner, a win for the environment. We can prove that we can greatly reduce the rate of flow that enters the stream. This particular pond reduces the peak flow by a rate of almost 1,300 gallons a minute. When depending on the rain, that's an average over 25 rain events. So it's even a bigger impact at a bigger rain event. This allows us to see this. This is in an ideal location where we have some forest, we have some pasture land. We're high up in the watershed, so that the watershed area, the catch basin that feeds this pond, can be mostly contained for an average or even a pretty big rain event. Actually, can be contained within this pond, and it will fill up during the extreme rain event as it's first falling, and first the water is coursing into the stream. And then it will slowly discharge. And then we extend that discharge point out. Instead of being hitting here and being gone in an hour or two, it takes it more than a day. So it slows down that rate of flow, extends it over a longer period of time. The same water flows. The same water that would normally flow down the stream still flows down the stream. It just hits it at a lower pace. So with this demonstration, we're hoping to show and acquire support for the concept of implementing this on a much broader scale. We need a lot of these ponds at this small size, an acre or so, to effectively reduce the flow in the entire watershed. And that is our goal, to reduce the flow, the peak rate of flow across the entire, in this case in the West Fork of the White River, which is the most problematic in our area, but there are others that need it as well, and put this situation back into a more natural perspective and operation, so that the rate of water that hits the streams can be contained by those stream banks. We can then repair the stream banks that have already been damaged, and they will then no longer have the rate of sediment and nutrients associated with that sediment that flow downstream. And this particular best management practice, if we can get it adopted on a widespread basis, we think will have a significant impact, positive impact, on the water quality of Beaver Lake.
What interested me in this project was that it fit in with some erosion control projects that I was trying to do personally, and it helped to speed that along and do it better than I could have done it on my own probably. One benefit of building the pond on this particular site is that we didn't have a pond for this side of the farm, and so it gives us additional holding capacity for water and a way to water the cows without using with city water. It's a big investment in time and money to start off, but to build this pond, but in the long run, with the cost sharing that was provided, then it makes it very affordable, and I hope it's something that can be expanded in this area to help some of our erosion problems. As far as working with the Beaver Watershed Alliance and Thad Scott, they've been great to work with. I've had no problems at all. Wouldn't hesitate to recommend them to anybody, and hope that they can get funding to continue this program for other people.